Hello and welcome to my first video presentation for doing archaeology. Today we are going to be taking a brief look into the process of electrical resistivity surveying. Along with going over what this method is and how it applies to archaeological research, we will also be going over the historical context, how it works, as well as some of the benefits and drawbacks of its application. Now without further ado, let's go over the practice of electrical resistivity surveying. Now what is resistivity surveying exactly? Essentially, it is a method of geophysical survey that involves the use of electrical current to measure the resistance or conductivity of subsurface materials. Since resistance can vary depending on different contents, moisture levels, depth, and other factors within the ground, archaeologists have used these measurements to locate discrepancies between the soil and archaeological evidence that may be within the soil. After patterns of conductivity are discovered, they are then recorded and interpreted to determine exactly what is present beneath the surface of researched sites. The original method of electrical resistivity surveying was developed by Dr. Frank Wenner in 1915 and was originally used by geologists to discover the locations of ore veins, aquifers, oil deposits, and other underground resources without the use of physical excavation. The method was later used for archaeological studies in 1946, where it would be applied in the research of pits and trenches associated with the Stonehenge monuments. Now, how does it work? Resistivity surveying works by inserting pairs of metal stakes or electrodes into the ground at equal distances in a line. From there, a resistivity meter is switched on, which initiates current between the first two electrodes. After this first cycle is completed, the current then moves to the rest of the electrodes, which serve to measure the resistivity, across the area of study until the voltage reaches the other end of the line. After all of the electrodes have had electricity pass through them, a display of the resistivity levels between all the points is then mapped. Afterwards, a process called inversion takes place, which mathematically compares ideas of what could be underneath the surface with the actual measurements recorded in order to figure out exactly what is underground. Now, what are the benefits of using this method? For one, the equipment itself is fairly easy to transport, as the major components really only consist of the resistivity meter, the cables, and the electrodes themselves. Secondly, the process does not require any physical excavation, which prevents any possible damage to evidence. Finally, resistivity surveying is very adaptable and can be used in a lot of landscapes, including deserts and glaciers. Now, some drawbacks of the method include the fact that analyzing more complicated structures can be difficult, as having only resistivity levels to work with leaves much open to interpretation. Secondly, the process can take a good amount of field time to set up, as it is quite a task to stake and connect all of the electrodes needed. Lastly, the process can be relatively expensive, with resistivity meters alone going anywhere from a couple $100 to a couple $1,000 depending on the quality. Now with that, I hope you got some helpful information regarding the process of electrical resistivity surveying. Thank you very much for watching, and have a great rest of your day.